Okay, so we're gonna get started now. Okay, so as you can see, this week we're gonna be learning about geometric sequences, which is sort of like the counterpart of arithmetic sequences, which hopefully you still remember from before the break. Okay. So what exactly is a geometric sequence? So in a geometric sequence, each new term is equal to the previous term multiplied by a number. And you may remember that arithmetic sequence, then each new term is equal to the previous term plus a number. Well, in a geometric sequence, we use multiplication. So for example, this sequence 1, 2, 4, 8, 16, etc. This is a geometric sequence because each new term is double the previous term. So you can see to get from 1 to 2, you multiply by 2. And then to get from 2 to 4, you multiply by 2. And then so on and so forth. Here's another geometric sequence. In this one, each term is multiplied by 3. So like 1, 3, 9, 27, 81. And the number you multiply in a geometric sequence doesn't have to be a whole number like 2 or 3. It can also be a fraction. So in this sequence, you can see that each time we're actually dividing by 3. But division by 3 is the same thing as multiplying by 1/3. So we say each term is being multiplied by 1/3. And this is a visual example of a geometric sequence. Someone last week said something about this. This is a geometric sequence because the number of circles doubles each time. Okay, Sai. Oh, okay. Sai, are you there?
Yeah, I was just taking attendance. I was filling out like the attendance sheet. My bad. All right. So a okay. So the number you multiply to get to the next term in a geometric sequence is called a common ratio, and that must remain constant throughout the entire sequence. So now you're gonna find out the common ratio of the following geometric sequences. So we have 4, 12, 36, and 108. And so what is the common ratio? 3. So yeah, 3 is the right answer because 4 times 3 is 12, 12 times 3 is 36, and so on. So that's right. And now how about this sequence? Yeah, 0.5, 1/2, those are the right answers because yeah, I mean that's pretty much self-explanatory. But yeah, those are the right answers. And I think this is the last sequence. Yeah, so -3 is also the right answer.
Yeah, and then this one, notice how the sequence, each term, it goes from positive and then to negative and then to positive and then to negative. This is because when you multiply a negative number by a negative number, it becomes positive again. So just be aware of that. Okay, so we're gonna do a quick
review. Are there any questions so far? Like, I'm just gonna ask that really quickly.
Oh yeah.
Do you have any questions on how geometric sequences work? All right, seems not, so you can move on.
Okay, so we're going to do a quick review on the difference between geometric sequences and arithmetic sequences. Once again, from our previous lesson before winter break, we learned that in an arithmetic sequence, a number is added to get the next term. And this number that you add is called the common difference. Now, in a geometric sequence, a number is multiplied to get the next term. And this number is called the common ratio. And I think this is pretty important. So if you're taking notes, you better write this down. I'm gonna give you a moment to do that. Okay, so now we're gonna look at a couple of sequences, and for this activity, you need to try to identify if the sequence is geometric, arithmetic, or none of them. So
to identify the common ratio / difference.
Yeah. Okay, so for this first sequence.
So chat. All right, what's the common difference?
Okay, so yeah, this is an arithmetic sequence with a common difference of 2 because each time the numbers increase by 2. Okay, now the sequence 1, 3, 9, 27, 81.
When you put the sequence step, also put like the common difference slash ratio when you answer.
Okay, so yes, this is a geometric sequence with a common ratio of 3. In other words, each time we multiply by 3 to get the next number.
Wait, how come there's only like 1 or 2 of you guys answering? There should be like 7 of you guys here. I think you guys need to participate more.
Even if you don't know the answer, if someone has put down an answer, you can just if you agree with that answer, you can put it in the chat even if someone has already like put down what you got. Okay, what type of sequence is this? 4, 5, 7, 10.
I want everyone to answer because like I think we went over these.
Okay, Kavya raised a hand. So do you have a question or like?
No, I did not mean to raise my hand.
That's
Okay,
fine.
that's all right.
So you guys were right. It's none because it's not arithmetic nor geometric since there's not a common difference nor a common ratio.
Yeah, because it doesn't increase by the same, it doesn't add the same amount each time, but it also just doesn't multiply the same amount each time. So it's neither. Okay, now this sequence.
Like put both of your answers in one line so they don't break up if multiple people answer. Yeah, so you guys, the people who answered, you're right, but make sure you put your common difference slash common ratio and the type of sequence it is on the same line. Yeah, so it is an arithmetic sequence with a common difference of 1/3.
Okay.
Now the sequence. Even if you don't know the answer, just put in a guess or look at someone else's answer. And if you agree with that, put it in the chat because that tells me that you're participating. I guess you could just put agree then. All right, yeah, so it is geometric with a ratio of 1/2. And yeah, I think that's self-explanatory. Does anybody have any questions so far? Like anything at all? Anything? Other questions? I'm gonna ask like again. So I mean, I don't think there are any questions because okay,
We can move on. All right. Oh, there's one more. Sorry. There's one more sequence.
Are there other types? I mean, other types of sequences. I mean, there's tons of other types of sequences, but the more like
these are the main ones.
Sequences is like such a broad term. Like, you know what I mean?
I mean, there are like different types of sequences. We're
Like
focusing.
you could consider the Fibonacci sequence a sequence, but it's neither geometric nor arithmetic. So yeah, there are a lot of different other types of sequences. the main two that we're focusing on are arithmetic and geometric, and all these other sequences are just special sequences which don't really matter unless you're preparing for like competitive math or something.
There's one more question at the bottom. I forgot it was here. This sequence, -1, 1, -1, 1, -1.
Oh, sorry. If you agree, just agree. So there's only one answer so far, and we've gone through a couple examples, so they should come faster. I want can you guys all put something in chat? Because I'm only getting one or two answers.
We've got 4 answers so far.
4? No,
Yeah.
I'm pretty sure.
Yeah, there are a couple.
Are those none from this one?
Yeah,
I thought
it's
those
from
were
this
from last one. Oh, all right, that's my bad. Oh yeah, last one's like number 3. Okay, my bad. Oh yeah,
Yeah.
sorry.
So Shreyam is right. This is a geometric sequence, even though it doesn't really look like it. But each time, to get from one term to the next, you're multiplying by -1. That's why this, even though like the 1 stays the same because 1 times 1 is 1, the negative it goes from negative to positive, negative to positive. So just like be aware of that, because these sequences can be kind of tricky.
So now we're gonna focus on getting like the nth term of a geometric sequence, and what that basically means is getting a specific term in a geometric sequence. So
Yeah, like if you wanted to find the 8th term, but you don't want to list out all the terms, then you can just use this.
And I highly encourage you write this down somewhere if you are taking notes. Okay, again, once more time. All right, so a of n is the nth term. So let's say I wanted to find the 51st term, right? I would plug in 51 in place of n, which is the term number you're trying to find. And then a is the first term of the geometric sequence. So if I had a geometric sequence that was 2, 4, 8, 16, and so on, the first term would be 2. And the common ratio, let's use the same sequence, 2, 4, 8, 16, is just the number you multiply each time to get to the next term. And so in that case, it'd be 2. So if I was trying to find the 10th term in a geometric sequence where the first term is 2 and the common ratio is 2, what would be the 10th term? You can just use this formula.
Sorry, they want you to repeat it.
Oh, sorry, my bad. So I have a geometric sequence in which the first term is 2, the common ratio is 2, and the term I'm looking for is the 10th term. Or in other words, the term I'm trying to find or solve for. So we have 180 as one answer.
We can show it on a Jamboard and work it out there.
All right, Amy, can you put the link of the Jamboard in the chat? Or is it already on the Google Stream?
Hold on one second. Oh, Shreyam, this is an exponent. It's raised to the n-1 power. So,
Line.
yeah. Okay, we can show it.
I will show it on a Jamboard. Here, give me the link to the Jamboard. I guess I'll just show it.
Yeah, I'll get it. Hold on. Okay.
Put it in chat as well. All right, so I'm gonna give everybody time to click on the Jamboard. Wait, I'm just gonna do like a test mark. Wait, can you like see the marks I'm making? Okay, cool. I can see the marks. Okay, cool. So the Jamboard works. That's good. Oh, Amy, it's view only.
Oh, well, we're
Oh, no,
not
you
gonna
can just do it. Yeah, it doesn't matter. Yeah, you can just do it.
wait. Sorry, you should be able to edit.
I can't edit, but it doesn't matter. You can just do it.
Okay, so in our question, we're looking for the 10th term. And the first term is 2, which means that this variable here, a, oh, is it not showing up?
Well, I can edit now, but yeah, you can just continue onwards.
Oh, okay. I don't think it's showing up. Wait one moment.
Wait, for you, on the Zoom meeting?
On the Zoom meeting, it's not showing up, so you can do
Wait,
it.
wait. It's not.
Yeah,
Okay. Well,
so
mark I made on. Okay, so it's okay. Whatever.
you
So
do it.
yeah. So the term that we're trying to find for is n, right? Okay, this is not exceptional penmanship, but it's 10. All right, this is what happens when you don't have a mouse, but it's okay. So it's 10. So the first term, a, I should probably type this out actually.
Oops. Dang it, now it's showing up.
I guess it's just latency. It's like a lot of lag. Okay, but it's okay. So the first term we're trying to find, a, is equal to 10. I mean 2, sorry. And the common ratio is also equal to 2. And we're raising the common ratio to the power of what? Well, we know that we're trying to find for the 10th term, n. n is 10. So then when we subtract 1 from 10, we get 9. So the power that we raise R2 is 9. So I'm just going to do that really quickly. So a of 10 is equal to, all right, so a times, which is 2, times, okay, that doesn't look like a times symbol, but it is, okay? So 2 times 2 to the power of 9, all right? So that's basically equal to 2 to the power of 10, because 2 times 2 to the power of 9 is equal to 2 to the power of 10, and 2 to the power of 10 is equal to 1024.
Wait, is there an easier way to like solve for the exponents rather than just multiplying it out like 100 times?
I mean, you could just do it on calculator, but
Yeah.
as far as calculating it, well, actually, you should know all your powers of 2s up to like 15.
No,
Like I
up
suggest,
to 10 is fine.
like up to 10 is fine, but like actually, you should be able to calculate this relatively easily. 2 to the power of 10.
Okay. Well, normally geometric sequences can get really big really quickly. So normally, you would get a calculator. So for this lesson, it would be fine to use a calculator, just as long as you're not hitting times 2, times 2, times 2. Don't just press times 2 like 10 times or something.
Like
Try
they
to
don't
just
have an exponents button.
they should have an exponents button on their calculator. It would be better if you just typed in 2 to the 10th power on your calculator. So yeah, for this lesson, you can use a calculator.
All right, so just move on with the lesson.
Yeah,
And
okay. Oops, that's not it. Dang it. Hold on 1 second.
does anybody have any questions about the formula? Hello? Any questions about the formula? Like what I just showed? Do you have any questions on how I did? Okay, no. Okay, goodness. No questions. That's great. Okay, Amy.
Yep.
I think we're on slide 9. On the next slide. Yeah.
Yeah, I'm not sure if this one is necessary. It just shows you where the formula is coming from, why it's like n minus 1.
Yeah, just go to the example.
Yeah, okay, we can go to the example. Okay. Okay, for this question, a geometric sequence has a first term of 3 and a common ratio of 2. Find the 5th term in this sequence.
I encourage you to use the formula.
Yeah, our intent is for you to like use the formula because just it's kind of time consuming to like.
Well, it just gives you practice on the.
Yeah, especially for like larger sequences where you don't want to like multiply it out like 15 times.
I'm gonna call on someone to tell me how they got their answer. Jivatish, seems like you've answered first. So I'm gonna call on you. Tell me how you did this problem.
Was that the correct answer?
Yes, it was from my
Okay.
calculator.
Well,
Yeah,
I forgot to do the formula. All I did was 3 times 2 and then 4 and then 6 times 2 until the 5th one.
oh, okay. Well, that's actually pretty. That's a that's an acceptable way to do it. But we are looking for using the formula. So does anybody like know how to do it using the formula? Anyone? All right. I guess that's no one.
Well, sure, and
Well,
put
actually,
something.
someone. Sriram. Hey, Sriram, do you want to unmute yourself and tell everybody how you did the problem? I guess that's a no. All right. So basically, first we're gonna identify all the variables. All right. So we know that the first term is 3. So lots of noise. It's okay. It's fine. Okay, I mean, I guess you can just put it on. But yeah, the first term is 3. The common ratio is 2, and we're trying to find the 5th term. So that means n would be 5. So then n minus 1 is 5 minus 1, which is basically 4. So 3 times 2 to the power of 4, 2 to the power of 4 is 16. 3 times 16 is 48. So that's how we got that. Does anybody have any questions? So I've noticed that a lot of you guys aren't putting your answers in the chat, meaning I'm going to assume that you guys have questions. So does anybody have questions?
Or does anyone want to see this on a Jamboard?
Thoroughly explained on a Jamboard.
R is the common ratio. So R would be what you multiply to get the next term in the sequence.
I think we should move on to the next example so they get more practice.
Yeah.
Move on.
Okay. This one. An infinite geometric sequence begins with these terms. What is the 7th term in this sequence?
And also, just a helpful hint for this problem, you just need to, firstly, you need to find the ratio. And once you find the ratio, you need to identify the first term, the ratio, and what n is. And then you input those into the formula and you get the answer. That's not helpful. That's kind of just how you solve the problem. Not really helpful.
Oh shoot. Sorry.
Okay. How about we do this problem all together as a class?
Well, we should just do it on the Jamboard.
Yeah, the Jamboard. Okay.
I'm sorry. My Zoom things keep disappearing, so I can't see it on any of the chat or anything. So.
Okay. You're all good, Amy.
Well, I wrote it on the Jamboard.
Okay, cool. Wait, second slide. Okay, yeah, that's cool.
Yeah.
So the ratio. So first of all, I'm gonna actually type this because it's more legible when I type. So first of all, we need to find the common. Oh, I'm gonna type. Okay.
All right.
All right. So first we need to find the common ratio. In order to find the common ratio, well, we know that the first term and the second term, they have that. When you multiply the first term by the common ratio, you get the second term, right? So that means when I divide the second term by the first term, I get the common ratio. So I'm going to simplify that and get 2/3. So that is a common ratio. So now that I have the common ratio, I need to find the first term. And it's obvious that the first term is 18, right? Because it's pretty straightforward. So it's 18. The first term is 18. And now we need to find n. So remember, n is the term that we are looking for. So the term that we are looking for is 7. So now that we have these 3 main components, we can solve the problem. So the first term, which is 18, multiplied by the common ratio, which is 2/3, and the common ratio to the power of n minus 1, and n is 7, so that would be 6. So then we solve for this, and there's actually a pretty, and then we just like multiply it out and stuff. So that'd be 2, 4, 8, 16, 32, 64. 64 over 729, if I'm not mistaken. So 64 over 729 multiplied by 18. Okay, and yeah, you can just use your calculator for this, I guess. There should be like, I mean, if you're doing this in the sprint round, we're not doing that in sprint round, but actually that doesn't really matter. But like you can just use your calculator to solve for this. So it's just 18 times 64, and then divided by 729. And I get
Your
around,
calculator may give you a very long decimal number. In that case, some calculators have a way to convert that decimal into a fraction.
really? Like actually? I didn't know that. Okay, can you tell me that thing for that? Like, is there actually a command for that?
Yeah, it's just there's a part on your calculator. I don't know, it's a little different, but it may be N over D or A over B. Like if you click it, then it may convert it into a fraction.
Okay, give me a syntax there. Well, okay, that's fine. All right. Yeah, but that's cool. Yeah, it's a feature you can use if you have it. Oh yeah, I have that feature too. Yeah. So I got a 128 over 81 on my calculator.
Yeah.
All right. Yeah. I mean, and just so you know, the feature is for my calculator, it's A B over C, and then it should show an arrow mark if you have these kinds of calculators, then D over E, and then you just press it and then press enter. So,
And again, just to recap what we did for this question, we first identified what the common ratio was in the sequence. Then we found what the first term was. And then the n is like the nth term. So in this case, we're looking for the seventh term. So n would be 7. Then once we get these values, we can plug them into the equation and just solve. Okay. So does anyone have any questions?
if you don't have any questions, then you fully understand what we're talking about, like what we're doing. So if there are those of you who don't like understand even a small part of what we're doing, please don't hesitate to ask. Well, if you have any other questions, just put them in chat. Okay, you can move on.
The answer was 128 over 81.
So yeah, it wouldn't be too hard, but it would be a little more difficult to simplify that. It'll be a little time consuming to simplify that. It might take a couple more seconds. So if you have a calculator, you can just use that very convenient function or command. All right.
Okay, for this third example. An infinite geometric sequence has a first term of 384 and a common difference of 3/4. Find the 8th term in this sequence. Again.
All right, so in this problem, we have everything that we need to solve, so you can directly input this. Actually, I also want everyone to answer the question since, I mean, we have everything and everybody should know the equation by now. So I want everyone to answer the question. And also, you probably won't be able to do this like by hand. So yeah, you definitely probably should use a calculator. And if you don't have a calculator, like a physical calculator, just use your Microsoft calculator. Just like press the Windows button, then type calculator on the search button, and then you'll get a calculator. So. And also one more thing, you don't have to answer this in fraction form because I don't know if the Windows calculator has
Either way, just like once you find the decimal, you can just put that into the chat
Put
if
it
you
in.
want.
Put in the decimal. Wait, what is 1 point parentheses 45? Repeat what?
I don't think, I'm not quite sure that's the answer.
No, I think that I don't. It's
No, I don't
oh
think that's
oh
the
he
answer.
doesn't have an exponent. Wait,
Oh,
no, that's
you don't have
someone
an
else.
exponent? Oh,
Oh,
no.
repeating decimal.
No,
Oh,
I don't think this should have a repeating decimal.
it shouldn't have a repeating decimal. Oh, are you talking about like the bar on top? I think the parentheses are supposed to represent the
Yeah,
bar.
yeah.
I didn't know that. Okay. Oh wow, Shri Ram. I mean, you're actually kind of close if you divide your answer by 10. So, I thought it was I thought it was the right answer when you divide by 10.
No, it's
Never mind. Yeah, I thought he just like accidentally put in the wrong put the decimal point at the wrong place. But never mind.
yeah, just recheck your work and make sure you're typing it in your calculator correctly.
I want everyone to answer if I have not said that before. Like, everybody should be able to answer this. Oh, you're
No.
wrong. You're wrong, but you can try again.
And if you don't have an exponent button, make sure that the exponent button on some calculators is it looks like this. It's just a upside down V. So just see if you have that button.
Bro, does everyone have a calculator? Because if you do, then you should be able to answer this. Maybe some people just don't have calculators. I don't know, but if you don't have a calculator, just put your answer in like the form, like in the equation form. Uh, well, that's wrong as well. Pretty wrong. Amy, do you want to? Why is it called a geometric sequence?
It's called geometric. Well, geometric. I'm not quite sure. Geometric
Oh,
generally.
if you think about it, right? A square is a square, and a cube is a cube, right? And so, and if you think about it, right, and like something squared forms a geometric sequence. Okay, I don't know. I'm just trying to.
I'm not really sure. It's just called that.
Why is
And by the way, Sanjay, you are very close. I think Sanjay
he's
is right.
I think
He's right. It's just you rounded one decimal place incorrectly, but I'm pretty sure you got the right
I
answer.
have an idea. What if we ask him how he did it? Sanjay, tell us how he did the problem. Sanjay, are you there?
Oh, are you calling me Sai?
Yeah.
For A1 I used 384.
That's
For
good.
for R I used 34. For N I used 8. And then to figure out the whole equation, I did 384 times 3/4 and like the 7 on like a with 8 minus 1 on top.
Yeah, that's right. And then
Right, good job.
Yeah, that's right. Okay, good job.
Okay,
And
that's amazing. You did it. You were the only one. Well, okay, so I think we're struggling on this more than I thought we were. Wait,
maybe it was just the calculator thing because
maybe it was just
yeah, sure. That's right.
I don't know, but yeah. So it's pretty straightforward. So in order to like find any term in any geometric sequence, you need to identify three things. You need to identify the term that you're solving for, the first term of the sequence, and the common ratio. Once you have all these things, finding the answer should be relatively straightforward.
Yeah, so in this question, like Sanjay explained, first we need to find what A is. And A is the first term, which we can look in the question. The question tells us the first term is 384. So now we know what A is, and we can basically replace A with 384. Then we need to find R. R is a common difference, and here it tells us it's 3/4, so we can replace that in the equation. And finally, it's telling us to find the 8th term in the sequence, which means that n is 8. So we can substitute that into the n minus 1 part. So n minus 1, or in other words, 8 minus 1 is 7. So we can, once we substitute everything, we get 384 times 3/4 raised to the 7th power. That's this little small number. We say like it's the number raised to the 7th power. And once you put that into your calculator, you get something like this, which is approximately equal to 51.25 or 26. Okay. So I hope the issue here was just that it was kind of hard to type it into the calculator. If you have any questions, please just ask. Yeah, you only put parentheses around the fraction, and then you raise the fraction to the 7th power. So fraction exponent 7. That's fine. Just make sure parentheses are pretty important, because if you just write 3 divided by 4 raised to the 7th, that can give you a weird answer. Okay, so, okay, no other questions? Okay, so we're going to move on. And hopefully you understand this, because now we're going to give you another important thing. How to find the sum of a geometric sequence. So what do you think is going to be the sum of this geometric sequence? 1, 2, 4, 8, 16. And note that the word infinite means that the numbers will just keep going on and on and on and on. They won't ever stop. And if you don't know, I want you to just guess, because okay, Shriyam gave a good guess. He used the formula and he wrote 1 times 2 to the infinity. And then he wrote -1. So does anyone else have any guesses? Okay, you said infinity, and so did Gary.
It is infinity.
Yeah, it is infinity, actually, because the numbers will just keep getting bigger and bigger and bigger and bigger. So, I mean, they're not going to get smaller. It's not going to turn into a smaller number. It's just going to be infinity. Now, this is a little different. This sequence is now a little different. So, what will be the sum of this sequence? 1/2, 1/4, 1/8, 1/16.
1. That's a very nice guess. Wait. So, you guys all know the formula, right?
Not for sums. Not for sums, Sai. It's just the nth term right now.
Oh, okay. I thought we already went. I don't know.
Yeah, we're about to introduce the sum. Okay, so some of you
is actually the wrong answer.
Some of you have put 1, some of you have put infinity, and others have put negative infinity. Actually, this sum will end up equaling 1. Even though there are an infinite number of terms in this sequence, each time the terms are getting smaller and smaller and smaller. And what ends up happening is that the numbers will start to approach 1. And when I say approach, I mean that like they would begin to like get very, 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 very close to the number 1. if you summed this, if you added up all the terms in this sequence, it would equal 1. And I'm going to show a visual which can help explain why. So here, first, this rectangle has an area of 1/2, okay? Because, okay, this long side length is going to have a length of 1. The short side length is going to have a length of 1/2. So this rectangle will have an area of 1/2. Now, if we add another rectangle, or in this case, it will be a square with an area 1/4, in which this side is going to have a length of 1/2, and this side is going to have a length of 1/2. Now, this whole, and if we keep adding, so now this rectangle will have an area of 1/8. Now we can add a square with an area of 1/16. And now we're adding a rectangle with an area of 1/32. And we continue doing that. You can see that's actually going to start approaching the square shape. And this square has a side length of 1. If we kept adding these squares and rectangles in this pattern onto infinity, this would make a square with a side length 1. So the sum of this sequence is just 1. And yeah, so notice, just remember that this sequence still has an infinite number of terms. Like, it never ends, but despite that, the sum will not be infinity. So, so here's something, yeah, it won't even get past 1. It will just approach 1, and it will get closer and closer and closer and closer. And if you add up all the infinite number of terms, it will just equal 1, but it won't ever go past it either. Yeah. So now here's a very important rule about geometric sequences that just go on and on and on forever. If the common ratio of that sequence is greater than or equal to 1, then this sequence will always sum to infinity, because the numbers will either get bigger and bigger and bigger and bigger, or the numbers will just, the numbers will just keep going. But if the
sum to infinity or negative infinity.
Or negative infinity, because there is a negative infinity.
And also, you can kind of think about it this way. Well, if we have a common ratio greater than 1, then surely at one point the numbers will be greater than 1. So then when you have infinite numbers that are at least 1, then you have a sum of at least infinity.
Yeah. But if the common ratio is less than 1, then this means each time the numbers are getting smaller and smaller and smaller and smaller. So what this means is that even though there will be an infinite number of terms, the sum will not be infinity. The sum will be what we call finite. Finite is just not infinity. It won't equal infinity. And yeah, so now we're going to introduce 2 important formulas about the sum of geometric sequences. It's kind of big, but this is a formula to find the sum of a geometric sequence with n number of terms. So n doesn't have to be infinity, but in this case, n is like how many terms are in the sequence. And we're going to explain how this sequence looks, this formula works. So Sai, you can explain this.
Yeah, so okay, so basically the A1 is the first term in the sequence, right? And then 1, well, everyone knows what 1 is. And then R is the common ratio, and N is the number of terms in the sequence. So then that's just our numerator. And then our denominator is 1 minus R. So an easy way to remember this is, we all know that 1 minus R there's going to be 1 minus R in the numerator and denominator. But the only difference is the R is being raised to the power of N in the numerator, and it's not in the denominator. So all you have to do is remember, I have an A1, the first term, multiply it by 1 minus R to the power of N, and then divide it by just 1 minus R. So it might look intimidating at first, but once you practice it more and more, it will be pretty simple.
Just to clarify, S sub, we call this little
S sub
letter,
N is
S sub N. This is just the sum. So
it doesn't cancel out because R is raised to the power of N, so it can't cancel out. They're not the same thing. You see that? Yeah, okay, cool. Okay, you can move on, Amy. Actually, before we want, wait,
there's one more thing. There's one more thing about this sequence.
Also, you should write this down.
Yeah, you should. write this down first, and then I'll show you something about the sequence that can make some problems easier. I mean, you don't have to buy a notebook. You be, I mean, you could
Yeah,
just
I mean,
use
I
the
suggest
back of your math notebook for school if you want.
I suggest that you take digital notes because then you don't lose it. Like I actually, so since the beginning of sixth grade for math accounts, I used to take notes of formulas and stuff, and it like I had it around 200 pages long. And then one day I lost it, and I never found it in the middle of the eighth grade. So yeah, and then from then on, I started taking digital notes on my Google Drive. So if you don't want to lose your notebook, then I highly suggest you do it on your Google Drive. Yeah, it was really sad. I was actually really sad that day. It was so super sad. I still haven't found it, by the way. Yeah, it's a fun fact.
Okay, we're gonna move on, and I'm gonna show you something cool about this formula. So
Well, I don't think it was like 200 pages long. It was around like 100, like more like. I was like, I think it was like 100-ish pages.
that's still a lot, though.
But yeah, okay, Amy will show you something.
Okay, so we mentioned an infinite geometric sequence. In an infinite geometric sequence, there's an infinite number of terms, but in this formula, n is the number of terms. So if we were trying to find the sum of an infinite geometric sequence, wouldn't n equal infinity? And then how do you like use that in an equation? Well, here's the thing. Technically, yes, n would be infinity if there were an infinite number of terms in a sequence. But if r is greater than or equal to 1, we know that the sequence will either sum to positive infinity or negative infinity. So you could just skip this formula and just don't use it at all. You can just sort of tell. But if r is less than 1, then the r raised to the n power part becomes basically, it starts to get smaller and smaller and smaller each iteration. So in other words, get your calculator, okay, and choose a number that's like less than 1 or greater than 0. So for example, I'm going to choose 0.5, okay? I don't know if you can see that. 0.5. If I multiply that by 0.5 again, the number is going to get smaller. So now it's 0.25. If I multiply that by 0.5 again, it's going to get smaller. And if I continue, you can see that every time it's getting smaller and smaller and smaller. And if you do that like an infinite number of times, what's going to end up happening is that this r raised to the n power part is going to be so small, you can just basically say it's 0 and just delete it. And now because r to the n is 0, 1 minus 0 is just 1. So now this entire part disappears. And now we get this new formula, which is actually smaller. It's easier to use. This formula is for if there are an infinite number of terms and r is less than 1 but greater than 0. Or in other words, the absolute value of r is less than 1. So this is for if like the terms will continue to like shrink. And you should probably write this down too.
I just wanted to say that if you don't have a exponent button, you after you just do like 384 times 2/3, you can just keep pressing the equals button, and then you'll just basically an exponent.
Yeah, that's a good tip. If you don't have an exponent button, you can just keep pressing the equals button and it'll keep multiplying the same number you multiplied by before. And yeah, you should probably also write this formula down. This formula is for only if it's the sum of an infinite geometric sequence where the terms are getting smaller and smaller and smaller. And again, R is the common ratio and A sub 1 is the first term. And now we're going to do some more practice.
Yeah.
Okay, so I'm just going to include the formula on the bottom of the slide because in case you weren't taking notes or something, I don't expect for you all to have it memorized already, but it's a good idea to try to memorize it because you won't be able to have notes in math counts. All right, so for this question, Sai, you can do this.
Yeah, sure. So we're gonna find the sum of a geometric sequence with 17 terms where the first term is 2 and the common ratio is 3. So we have 3 main things that we need in order to solve for this. Well, we need the first term, which is given. We need the common ratio, which is given, and the number of terms is also given. So then we just input everything. So the first term is 2. So a of 1 is a sub 1. A of 1 is 2. Then in the parentheses, we get 1 minus in the common ratio to the power of the number of terms. So 3 to the power, 1 minus 3 to the power of 17. And then we divide that by 1 minus r, which would just be 1 minus 3, so negative 2. So, and then we know that the first term is 2. So that means the 2 and negative 2 cancel out to get a negative 1 in the numerator. So it'd just be negative 1 times 1 minus 3 to the power of 17. And you would definitely have to do that on a calculator.
Yeah, if your calculator doesn't have an exponent button, you can just either multiply. I mean, it'd be kind of hard to multiply that, but
You definitely can multiply.
yeah, you could either multiply it out on your calculator instead of using the exponent, or you could just write the equation in the chat with everything substituted inside.
Yeah, so the answer is actually 9 digits.
Yeah, it's pretty big.
Yeah, it's 9 digits, so.
Um, 1 minus 3 to the 17th isn't the negative version, but it's pretty close to the negative version. The negative version would just have negative 3 to the 17th. But in this case, it's 1 minus 3 to the 17th. It's very close, but it's not exact. So, oh.
I essentially gave you guys the answer.
Yeah, what you might want to do is use parentheses and multiply it and just type the whole thing in because the calculator might do some weird rounding, which might mess up your answer. Either way, you're going to probably get close. And it looks like Sanjay got the right answer. Good job. So, yeah, that's the right answer, Sanjay. And Shriyam now. So, good job.
Yeah, also, you guys, I'm gonna ask some. I'm gonna pick on someone to see how they got the answer, if that's okay. Actually, no, I don't think that's necessary because.
Actually, Sai, this slide has something to show that. We can choose someone for one of the other questions.
And that's been, and also, it's just like, you know, like, it's like just a lot of calculating work.
Yeah. Anyway, to solve this problem, again, you would have to identify what the first term is, what the common ratio is, and how many terms there are in the sequence, and then you insert it into the equation. So first, the question says that the first term is 2. So we take 2, then we substitute it in here. Okay. Next, it says that the common ratio is 3. So we take 3, and then we also substitute it for r. And then it says that this sequence has 17 terms, which is n. So we take 17, and then we substitute for n. And now we basically have our answer. We just need to type it in the calculator. So if you manage to successfully type it in the calculator without messing up on any of the digits and getting all the parentheses right, you would get, yeah, this big number. 129,140,162. So good job to Sanjay and Shriyam and anyone else who got that. Okay, for this sequence, this next example. Find the sum of the first 10 terms of a geometric sequence with a first term of 7 and a common ratio of 2. And again, you would take a similar process to what the previous question had. Yeah, Shriyam, that is true. Now, no. For this question, the -2 has to be in parentheses. So if you subtracted -2, it would be the same as adding 2. But in this case, the -2 is separate. So really, it should be, make sure when you're typing in the calculator, you type 1 minus -2 to the 10th. If you don't include the parentheses, it will give you the wrong answer. I'm not sure that's right. Okay, it's almost time to go. Well, it is time to go. So I'll quickly explain. The answer to this problem would be, yeah, Shriyam, that's right. You would just have to simplify that. So the answer to this question would be -2,387. And again, we just need to identify the values for A1 and R and N and substitute the given values into the equation. So first, A1, or in other words, the first term is just 7. So we can replace that with 7. And then R is the common ratio, which it tells us that the common ratio is -2. So we can substitute that into the equation. And really, there should be parentheses around -2. And then the N is just the sum of the first, N is 10 because we're looking for the sum of the first 10 terms. So we raise -2 to the 10th power. And again, there should be parentheses around -2 because if you don't have parentheses, then it will do 2 to the 10th instead of -2 to the 10th. Well, either way, they give you the same answer, but you need to include parentheses. But yeah, if you type this into the calculator correctly, you should get -2,387. So, yeah. And yeah, we're out of time. We didn't cover everything today, so I'll just modify the quiz so it doesn't include the things we didn't cover. If anyone has any questions, please ask. So